You know, when people talk about the future of artificial intelligence, they usually paint this incredibly abstract picture.
Oh, absolutely. It's
Yeah.
all glowing blue brains and like infinite streams of floating code.
Right, algorithms that just live up in the cloud somewhere. And they talk about it as if the cloud is this magical, weightless place. But if you actually walk into an AI data center, that illusion shatters immediately.
Yeah, instantly. It is incredibly loud, it's blindingly bright, and most importantly, it is heavily, heavily physical. I
Exactly.
mean, it's the absolute definition of heavy industry. It just looks like blinking lights and endless server racks instead of smokestacks, you know?
Yeah, you're dealing with miles of thick cabling, massive steel infrastructure, and just a terrifying amount of electricity flowing into these buildings the size of shopping malls.
Massive.
So today we are looking at a hidden architectural war over these physical superhighways. A war where the winner isn't the one who builds the smartest chip, but the one who stops the data center from literally melting down.
Right, which is a very real threat right now.
Welcome to the deep dive. For you listening right now, our mission today is to unpack a fascinating stack of market notes, a recent report from Digitimes, and, well, one very specific photograph of a piece of hardware that crossed our desks.
We're basically going to map out the physical plumbing that is actually powering the AI boom.
Which is so crucial, and this is a critical moment to be mapping this out, considering the timeline our sources are pointing to. Today is April 27th, 2026.
Right, 2026.
Keep that date in the back of your mind, because our sources repeatedly point to the second half of this year, H2 2026, as the tipping point.
This is the moment slated for, like, the volume production and mass adoption of a truly transformative piece of technology.
We are standing right on the precipice of a massive shift here. But if you showed the average person the photograph we have in our source materials, they wouldn't even look twice at it.
Oh, no. They'd probably think it was just, I don't know, an old piece of computer junk.
Yeah, let me describe this image for you so you can picture what we're talking about. It's a photograph of a small, rectangular, silver metal box.
It's tiny.
Yeah, it looks a bit like a really thick, elongated USB thumb drive. It has this distinct, bright yellow plastic pull tab on one end and a little black optical port on the other.
Like you said, it doesn't look like much. It fits right in the palm of your hand.
But this unassuming little silver rectangle is a 1.6T optical communication module.
Which is arguably the unsung mechanical hero of the entire artificial intelligence revolution.
Okay, let's unpack this. Everyone is completely obsessed with the AI software, right? The large language models, the generative video.
The flashy stuff.
But without these little silver boxes, the AI revolution completely stalls out. So why is this specific piece of hardware creating such a frenzy in these analyst notes?
Well, to understand the highly nuanced market plays hidden in our notes today, you first have to understand the baseline. You know, what is happening in the broader AI data center market right now.
Right.
The Digitimes excerpt in our stack lays this out perfectly. It states explicitly that 1.6T optical communication modules are set for broad adoption in AI data centers in 2026.
Meaning the biggest tech companies in the world are buying them all at once.
Exactly. Millions of them. The optical transceiver vendors and the key IC that's integrated circuit design houses are currently preparing for massive, unprecedented shipments. Because when we talk about a 1.6T module, we're talking about 1.6 terabits per second of data transfer.
That is a staggering volume of information.
It's insane. We are talking about converting electrical data into pulses of light, shooting it through a fiber optic cable, and doing that at a rate of 1.6 trillion bits every single second.
Okay, to give you a mental image for this, think of an AI data center as a massive, incredibly fast brain. These 1.6T modules are the optic nerves.
That's a great way to look at it.
They are the physical pathways allowing the different lobes of that brain, like the different server racks and processors, to talk to each other fast enough to process a complex thought.
Right, because if you have the smartest AI chips in the world, but they can't share their calculations instantly.
The brain is basically paralyzed.
Exactly. That connectivity is the defining bottleneck of modern computing. And right now, the sources point to some massive, obvious beneficiaries who are providing the hardware to open that bottleneck.
Which the notes lay out pretty clearly.
Yeah, the report cites Broadcom, ticker symbol AVGO, which provides the digital signal processor, or DSP chips, that actually go inside these modules.
Okay.
It also highlights MRVL, ticker MRVL, providing fully integrated solutions. The market notes we have suggest that going long on these upstream supply chains, quote, doesn't hurt.
But wait, if Broadcom is already a massive tech giant, isn't Wall Street already pricing that in?
You think so, yeah.
I mean, if you're listening to this deep dive and following the market, you probably already know Broadcom makes the chips for everything. So why are these analyst notes treating this like a major revelation? Are we just telling the listener that big tech companies are going to continue making money?
Well, if we connect this to the bigger picture, the mainstream players provide the safe baseline infrastructure.
Right.
The analysts mention them just to establish the foundation of the current supercycle. But the truly fascinating dynamics and, like, the potential for massive disruption lie in the highly specialized companies
Ah, okay.
and the upcoming architectural shifts that most people simply aren't watching closely enough.
So the giants are the rising tide, but we are looking for the specific boat's position to catch the most wind.
Beautifully put. And that brings us to the first major strategic play outlined in the notes. The sources single out a company called AAOI.
That's applied optoelectronics, right?
Yes. They are singled out as arguably the most profound beneficiary of this entire 2026 hardware supercycle.
Profound beneficiary is a very deliberate choice of words for a financial analyst. Why them, specifically, over a giant like Broadcom?
The notes point to a concept called pure play exposure. The projections show that AAOI will have the largest 1.6T capacity in the United States.
Okay, let me see if I can visualize the difference in leverage here. If diversified revenue is like a massive floodlight, illuminating a wide area but keeping the energy somewhat diffuse across many different products, then pure play exposure is like taking that exact same energy and focusing it into a laser beam that cuts right through steel.
That highlights the financial mechanics perfectly. Broadcom makes incredible money on their DSP chips, sure, but their revenue is spread across dozens of sectors.
Right.
When H2 2026 hits, and the entire AI industry scrambles to buy 1.6T modules, a company like AAOI, whose operational capacity is aggressively dedicated to this specific bottleneck, is going to experience a much more concentrated financial impact.
Right, because if 100% of your business is suddenly the single most important thing in the tech world, your market valuation is going to reflect that reality a lot faster than a conglomerate.
Exactly. For Broadcom, this supercycle just means one division had a really good quarter.
Yeah.
But finding a pure play in a moment of mass adoption means a company doesn't just benefit from a trend, their entire corporate trajectory is propelled by it.
But if AAOI is making a fortune selling these modules right now and Broadcom is charging a premium for the DSP chips inside them, wouldn't the big hyperscalers, the Googles and Metas buying millions of these things, immediately start looking for a cheaper, less power-hungry alternative?
Oh, they absolutely would. The tech world never stands still, right?
Right.
Hardware is a constant arms race.
Always.
What is cutting edge in H2 2026 becomes the expensive baseline in 2027. And our sources point to a Wave 2 architecture timeline kicking off around H1 2027.
So the first half of next year.
Exactly.
Here's where it gets really interesting. This is where the notes introduce a totally different strategy. They position Jabil, ticker symbol JBL, as a good contrarian along for this Wave 2.
Yeah.
And the reason why requires us to look inside that little silver box. Jabil is betting on something called LRO architectures. LRO stands for linear receive optics.
Yes.
Crucially, the notes emphasize that this LRO architecture completely removes the DSP.
They're stripping out the most complex part of the entire module.
Right. And the notes mention that instead of the DSP, Jabil is using Intel's silicon photonics, or SIPE acquisition IP.
Correct.
Wait, hold on. Let's translate this before we go further. Silicon photonics and acquisition IP. How does silicon replace a digital processor? And what does acquisition IP even mean in this context?
Sure, let's break down the terminology first. Acquisition IP just means intellectual property that Jabil acquired. They basically bought the underlying blueprints and patents for this specific technology from Intel.
Oh, I see.
They now own the right to build it.
So they bought Intel's homework on how to do this.
Pretty much. And silicon photonics is the actual technology. For decades, computer chips, which are made of silicon, have processed data using electricity.
Right.
Fiber optic cables, on the other hand, transmit data using light or photons. So silicon photonics is the incredibly difficult engineering feat of merging those two worlds. Yeah, it's building silicon chips that can directly manipulate and guide light without constantly converting it back and forth into electricity.
So Jabil wants to use this light-guiding silicon to replace the DSP. But let's look at the mechanics of why you would do that. We just established that the DSP chip is the brain of the current 1.6T module.
Right, is.
Why would Jabil's Wave 2 strategy actively delete the brain from the equation? Isn't that an incredibly risky pivot for Jabil?
To understand why it's a brilliant but, yeah, highly risky move, we have to look at what happens during a single microsecond of data transfer.
Okay.
When a pulse of light travels through miles of fiber optic cable at 1.6 terabits per second, the physical signal gets messy. It degrades, it scatters slightly, it picks up
It's
noise.
traveling a long way very fast.
Exactly. The DSP, the digital signal processor, acts as a digital cleanup crew. It takes that messy, raw analog light, converts it to digital data, does heavy mathematical processing to fix all the errors, and outputs a perfectly clean signal.
It's like having an editor read a manuscript, fix every single typo, and retype the whole thing perfectly before handing it to the publisher.
That's a perfect analogy, but doing that math requires electricity. A lot of it. And whenever you run heavy electrical current through a processor, you generate heat.
Right, the natural enemy of electronics.
In an AI data center packed with tens of thousands of these modules, power consumption and heat generation are your absolute worst enemies.
So Jabil is looking at this and saying, what if we just don't clean up the signal digitally? What if we fire the editor?
That is the core of linear receive optics, or LRO. It proposes keeping the signal in its raw, analog form. They use the silicon photonics they acquired from Intel to capture and guide the light efficiently, but they completely strip out the heavy computational math of the DSP.
Wow. So it makes the module cheaper to build because you aren't buying chips from Broadcom. It drastically lowers the electricity required to run the module, and most importantly, it cuts down the heat.
Yeah, exactly. But, you are trading heat for complexity elsewhere.
Oh,
Well, by removing the DSP, you are relying on the rest of the network's hardware to handle that slightly messier, unprocessed analog signal.
the messy manuscript.
Right. Which brings us to the biggest caveat in the sources. The notes explicitly state that Jabil's broader market adoption hinges heavily on validation from Meta.
Because Meta operates some of the largest AI clusters on the planet.
Exactly. You can design the most elegant, power-saving architecture in the world, but if the massive hyperscalers don't adopt it, it's just an interesting science experiment.
Yeah, it goes nowhere.
Meta has to test Jabil's DSP-less modules in their actual data centers and officially declare, yes, our systems can handle this raw analog signal. We validate this architecture.
And if Meta validates it, Jabil's contrarian bet pays off astronomically.
Oh, huge.
It essentially crowns a completely new industry standard for H1 2027. It allows the hyperscalers to bypass the expensive heat-generating DSP components that the current wave relies on, and it just completely rewrites the supply chain.
It's literally a high-stakes poker game over the physical infrastructure of the internet. And a fundamental change like that, completely changing the internal blueprint of a transceiver module, doesn't just impact Jabil and Meta.
Right.
It sends massive ripple effects all the way down the supply chain to the companies making the raw, foundational components.
And that brings us to a really interesting connection in the notes. The sources trace this exact ripple effect down to another company, SIVE, which they say powers Jabil's 1.6T LRO architecture.
Yes.
SCV provides the lasers.
Right. The crucial takeaway the analyst provides is the cascading nature of this relationship.
Okay.
If Meta validates the LRO architecture, Jabil scales up production massively. When Jabil scales, Esses scales. The note specifically points out that this directly scales laser demand across the board.
So what does this all mean? Let's look at the underlying logic here, because there's a gap that needs explaining.
Sure.
If you use a traditional module with a DSP, you are transmitting data using light. If you use Jabil's new LRO module, you are still transmitting data using light. Both architectures require lasers. So why does Jabil's specific shift to LRO uniquely skyrocket the demand for CV's lasers? It sounds like we're looking at the ultimate pick and shovel play. You don't just bet on the gold rush, you bet on the specific lasers powering the new shovels.
What's fascinating here is that it comes down to the physics of removing that digital cleanup crew.
The editor.
Right. In a traditional module, the DSP is your safety net. Because you know the DSP is going to mathematically fix the signal at the end of the line, you have a little bit of margin for error at the starting line.
Ah, I see. The initial laser pulse doesn't have to be absolutely flawless because the editor will fix the typos later.
Exactly.
Okay.
But with linear receive optics, you have removed the editor entirely. The signal stays raw and analog the whole way through.
Wow.
Because there is no digital safety net to clean up a degraded signal, the initial light source has to be exponentially more powerful, more precise, and purer.
So they need a better flashlight, basically.
Way better. You need extremely high-quality continuous wave lasers to punch through the noise so clearly that the raw signal is still readable at the other end.
And SIVE specializes in providing those flawless, high-power continuous wave lasers.
You got it. Jabil's architecture inherently demands a much higher tier of optical physics to work.
By understanding that mechanism, you see why the analyst highlights SIVE. If Jabil wins the Wave 2 architectural war, the demand for high-end, flawless lasers spikes drastically to support the LRO systems.
SIVE's specialized technology becomes the foundational pillar, making the DSP-less design physically possible.
This entire ecosystem is so deeply interconnected. When you trace the wires all the way back, it literally comes down to the fundamental physics of generating a perfect beam of light.
Right. We constantly look at the software side of AI, the billions of parameters, the complex algorithms, but the reality of making that software run rests entirely on these hardware constraints.
It's all physical.
From the massive generative AI models demanding infinite data transfer, down to Jabil taking a contrarian bet to save power, down to SIVE having to engineer a better continuous wave laser.
Let's pull all of this together and recap the journey we just took through these sources. For you listening, trying to grasp the reality of the AI boom, it is critical to remember that this isn't just a software race.
Not at all.
We are tracking a heavy industrial manufacturing race that is hitting major checkpoints over the next 12 to 18 months.
Starting right now with the immediate H2 2026 supercycle.
Right. We have the broad adoption of 1.6T modules. You've got the giants like Broadcom and Marvell providing the established baseline DSP and integrated solutions.
The rising tide.
Exactly. Then, positioned within that same wave, you have the aggressive, concentrated, pure-play capacity of AAOI, acting as the specialized laser beam ready to capture the immediate demand for these modules.
And looming just over the horizon in H1 2027, the market notes map out the Wave 2 battle.
Jabil stepping into the ring as the contrarian bet. They are trying to solve the massive heat and power problem by dropping the DSP entirely, using silicon photonics to push a raw analog signal, and praying that Meta validates their linear receive optics.
A move that, by its very physics, drives a massive foundational spike in high-end laser demand through suppliers like SIVE.
It is a phenomenal stack of sources because it pulls the curtain back on the entire chessboard. You get to see the safe foundational bets, the highly leveraged pure play bets, and the looming architectural paradigm shifts that could upend everything.
It really highlights how fragile and dynamic this infrastructure is.
I want to leave you with a final thought to mull over as you watch this market evolve. We spent a lot of time talking about this fierce architectural battle, the traditional DSP-heavy modules versus the stripped-down LROs.
Yeah.
As AI models continue to grow exponentially, requiring more processing power and infinitely more data transfer, the physical limits of our infrastructure are going to be tested like never before.
Oh, absolutely. The demand for data transfer is only going to compound.
And we might be looking at the wrong bottleneck. Everyone focuses on making the chips faster, smarter, and more complex.
Yeah.
But when you think about Jabil's strategy of removing the processor entirely just to save power, it highlights a terrifying reality for data centers. The ultimate winner in the hardware wars over the next decade might not actually be the company with the most complex, brilliant silicon.
Oh, that's a great point.
The winner might simply be the one whose stripped-down architecture generates the least amount of heat.
Because eventually, you just can't pump enough cold air into the room to stop the servers from melting.
All those beautiful, glowing blue brains and weightless clouds of code. At the end of the day, their entire existence is at the mercy of how much thermal energy a tiny silver metal box with a yellow pull tab can dissipate. Keep a close eye on H2 2026. Catch you on the next deep dive.